Hi, we are still in Module 9. This time we're up to pages 293 through 298. This video will lead you up through page 295, but then on your own, you need to look at the examples in the following pages and take your own notes if you feel that that is helpful to you. It's always helpful to me to take my own notes and be able to read it and then also write it down. So I will instruct you to do that at the end of the video. So we're talking about molecular shapes. We've learned about the tetrahedron and we've learned about the pyramidal shape. The third shape is called the bent shape. Number 3 is the bent shape. And you can see this in figure 9.3. The bent shape occurs again with 4 electron groups, so we're going to base this shape again off of the tetrahedron. Occurs with 4 electron groups but this time 2 are non-bonding electron pairs. So before you're able to predict these 3D molecular shapes, you really have to draw out the Lewis structure to see how many electron groups you're going to have, how many bonds that is there are, and how many non-bonding electron pairs there are. So with each of these shapes, I will first draw the Lewis structure and then we'll see how that translates into the 3D molecular shape. Okay, so this one also resembles a tetrahedron, but this time we have 2 legs of the 4 missing. Oh no, my 2 legs are missing! I am now a bent shape. Just have to try to throw in a little humor to lighten the mood a little bit, however bad it is. Okay, the bond angle for these is going to be, again, slightly smaller because this time we have 2 electron pairs, 2 non-bonding electron pairs that like their elbow room. So they're pushing against those bonds and squeezing those bonds together just a little bit more. So this time the bond angle is 105 degrees. So each time the bond angle is going down by about 2 degrees because we started at 109 with the tetrahedron, 107 with the pyramidal, 105 now with the bent shape. For example, we're going to take a look at our beloved molecule, H2O. Okay, the Lewis structure. When we draw the Lewis structure, we start with the central atom. The O has 6 valence electrons, so it looks like this. And we can see that each of its lone electrons here is looking to find a partner, right? So it's going to share an electron pair with hydrogen. So as you can see, we have 4 electron groups, 2 of them are bonds, and 2 of them are non-bonding electron pairs. When we have this type of Lewis structure, the 3D structure, we flip it around a little bit, I guess just because it's a little bit easier to see the bent shape in this direction. But we have the O in the middle. One of the H's can come straight up. One of the H's comes off to the side. And then you can imagine the tetrahedron also has a leg coming out toward us and a leg going behind us, but those 2 legs are missing. They're just the electron pairs. So we just draw in the electron pairs. And remember, those electron pairs stretch out and they push these bonds in a little bit farther, so the bond angle is 105 degrees. So that is the bent shape. With my toothpicks and marshmallows here, I still have my pyramidal shape kind of here. So again, if we took away another one of these legs, we would end up with a bent shape, 105 degrees here. That's shape number 3. Shape number 4 is the trigonal shape. Hi, Sammy. Yes, you can take a nap.
I already fell asleep.
Oh, okay. That's my favorite son. Don't tell Jake. I'm just kidding. I don't have a favorite child. Trigonal shape, see figure 9.4. Okay, a trigonal shape occurs when, this is the first one that's not based on the tetrahedral shape, the tetrahedron. This time it occurs when there are 3 electron groups. About time that we switch that up, right? 3 electron groups around the central atom. Why, you say? How can there only be 3 electron groups? Well, because one of the electron groups is a double bond. So there is a double bond involved for this shape. Our example is going to be CH2O. Let's draw the Lewis structure. The Lewis structure would have, you have to draw out the Lewis dot structure for each of the molecules to see which was going to be the central atom. But we would find that carbon would be the central atom because it would have the most lone valence electrons like this. Okay, and then 2 of these lone valence electrons are going to double bond to oxygen. And then oxygen would have 2 more pairs of valence electrons. And then these other 2 valence electrons of carbon, one would share with hydrogen, one would share with the other hydrogen. So that's what the Lewis structure would look like. So you can see how now we have 3 electron groups, okay? And if you were to play around with marshmallows and toothpicks and try to see how you could make it so that the electrons would have the most space so that the bond angle would be the greatest possible, it actually is just going to be, it's really just a 2-dimensional figure. And it would look like this. Doesn't matter in which direction you put anything, but one of the bonds would be going straight up. One of the bonds would be coming off to one of the sides, the other would be coming off to the other side. And the bond angle in between here would be, think about it, if a full circle is 360 degrees and you wanted those bonds to be as far apart from each other as possible, they would each get 120 degrees, right? So the bond angle would be 120 degrees. And again, we'll play around with these shapes in class so you can see that that is how the electrons get the most space. And we have just one more shape. I hope I don't run out of time in my 15-minute video. So I'm going to try to quickly get through that one. And then you'll see in your reading that after you can read about each of these 5 shapes, there are some examples. And I want you to go through those examples on your own. I would encourage you to take some notes on those examples, to add those into your notes. And then there are 3 on your own problems that you can also try. All right, our last shape, number 5, is the linear shape. This occurs when there are, guess how many electron groups? 2. We're down to only 2 electron groups. Okay? So how does that happen? That would happen if there are like 2 double bonds or maybe 1 triple bond involved. Double or triple bonds are involved, so that you only have 2 electron groups around the central atom. Or it can occur, or occurs if there are only two atoms in the molecule. Okay? I kind of messed this up in your notes. I'm sorry. Let me give you an example of this lower one first. For example, if there are only two atoms involved, that would be like a homonuclear diatomic, for example, F2. The Lewis structure would look like this. And so the three-dimensional figure would just be like this. There would just be, as far apart as they can get from each other is 180 degrees. Okay, so it's at a 180 degree angle. So again, this is a shape that really is just two-dimensional. Moving, you can't put two atoms into a three-dimensional kind of shape. And then the other example, I'm sorry, it was for this one up here, so I'm gonna have to draw an arrow. I hate it when I mess up notes. Sorry. For example, CO2, the Lewis structure would look like this. There would be two double bonds, one on each side of carbon. And then the oxygens would have their extra valence pairs out there. And again, the bond angle here is 180 degrees. So it's just a straight line, and that's as far apart as the electron pairs can get, 180 degrees for that. And that's called the linear shape. Okay, so those are all of the notes that you're going to get from me. I also want to direct you to these steps right here on the bottom of page 295. Now I could copy these down so that you copied from me, copying them down from your book, but that just seems silly, doesn't it? So I want you to take your own notes for sure on these steps for determining the shape of a molecule. So you can do your own kind of shorthand script or however, but understand how to determine the shape of a molecule, and then go ahead and work through the examples. And there are some on your own problems to try. And I will see you next time.